The environment can only support so many. It can only carry so many individuals. So again, no net change in bacterial numbers because some are still dividing, but an equal number are dying off. Now, what's going to happen? I've accumulated wastes. It's very crowded. There's no space for anyone else. We're using up nutrients. If I have an inclusion, I'm going to start using it because competition for nutrients is really stiff here, right? And eventually, the whole population is going to age and start to die off. Too many wastes have accumulated, not enough space, maybe not enough oxygen if they require oxygen. But is everybody going to drop dead at once? If everybody did drop dead at once, there'd be a straight line going down to zero. But that's not what happens. Older ones die first, younger ones get old and then they die, and then they die. So it's an exponential decrease. Notice this part of the curve is the exact opposite of this part of the curve. So they're going to die off at the same rate that they replicated. They're going to die off exponentially. So they call that the decline phase. Some people call it the death phase. It's an exponential reduction in numbers, exponential decrease in bacterial numbers. Because they don't just all die off at once. That would happen if a meteor hit the earth or a Petri plate, then they'd all die at once. So we did bacterial growth curve. And the rest of that crap, you don't have to worry about. Just put it in there so you'd see. This is a cell counter, or a hemostat, they'll call it, if you're counting red blood cells, but you can also use it to count bacteria. These are just interesting things that you should be aware of, but we won't get tested on. And then we're going to do a serial dilution in lab, so you might want to look at that when the time comes. And I'll show you how to do one in lab. And what else we got? Probably a million freaking slides here. This is another one just to show you how filters can be used. Different ways of estimating the size of the population. Turbidity, remember, you can actually assess how turbid it is. You get an estimate of how many bacteria. So these are all ways to sort of count the population. Growth factors. These tables I don't expect you to memorize. I just want you to notice what they're about. What do microbes need? They need amino acids, cholesterol, mycoplasmas, right? So, where do you get your clinical specimens from? Urine, lungs, whatever. Most probable number table. Number out of 5 tubes giving positive results of 3 distributions. Most probable number is a way of quantifying bacteria. Okay, there you go. Visualize it. I don't know what it is. Sorry about that. It was probably supposed to be a movie, but it didn't come over.
Oh, thank you, dear.
Take my notes out.